Welcome everybody, my name is Jan, I'm from the Dutch office in Leiden. I'm going to talk to you about ways to incorporate third-party software like statistical programs into the Diver solution. I'm going to talk to you about statistics. I know that statistics isn't the most sexy subject to talk about, but don't worry, I'm going to keep it applied. And the reason why is because when I went to university I had to pick a course to follow, and I knew I had to do something with mathematics because I'm not just good at mathematics, but I really like it. But one of the most important things in my work is that I actually want to apply this math and actually do puzzles and create solutions that people can actually work with. I studied business mathematics, which is an applied kind of mathematics, and our slogan or our statement of our course was, we're going to be nerds in suits. So that's why I'm here. I'm going to be a nerd in suit, and I'm going to entertain you about ways to incorporate mathematics like statistics into the Diver solution. So this is the main course, the main point that I'm going to be talking about in this presentation. First, I'm going to give you a refresher on the production. Then I'm going to talk to you about R and why R is so hot and happening. Third, I'm going to show you using DR production extensions, what they are and what their use is. I'm going to end up and round up with a use case in which we put all these things together. First, I'm going to talk to you about DR production. DR production is a way, it's a process flow management tool, and it's a way to combine your scripts all together. And it has the look and feel of Visual Integrator, and you can consider it to be DI scheduler on steroids with some extra functionality. Everybody's got scripts running mostly during the night, and most people can be using either DI scheduler or Windows scheduler or things like that. DI production is the next thing. It makes your life easier. DI production basically has 4 different kinds of functionality. First, it allows the running of scripts like integrator, builder scripts, or anything from command line. Second, it allows some file system functionality, like moving files, copying files, zipping, or downloading files from FTP. Third, it allows conditional and parallel computing, which means that you can have logic in your script saying, if there are new files, then build all my models at the same time, increasing the rate of computation. So let's go out. And the fourth thing, of course, is the option for scheduled alerts. So if one of my node fails, then send an email to the right owner of the issue. So this is an example of a DR production script. I'm not going to go all the way into details, but as you can see, there's plenty of nodes, there's conditions, there's checks, and one of the most important things, or one of the most fancy functionality there is that it automatically validates my data in a validation script in here. And if any data validation errors are found, it automatically sends an alert email to the employee that's in charge of data quality. Okay, so I've been talking about DR production. Next thing, it's R. Okay, for those of you that have never heard of R, it's hot, it's trending, it's hip. R is not just a letter, it's an entire language. It's a statistical language, and you can see it as an open source version of SPSS or SAS. The great thing about open source means that it's free to use, and it's used by universities all around the world, basically because it's free, and there's a gigantic community of users creating their own packages and creating their own functional libraries, which are centrally stored and available for anyone that wants to access that. So I know that many companies are using either SPSS or SAS for their functional analysis or their statistical analysis. But if you're a nerd in a suit like I am, you'll probably want to go with R. So, in statistics, there's basically two major strands of what we're doing in statistics. On one hand, we're trying to explain what's happening, so we're trying to explain the past by finding patterns in your data. On the other hand, we're trying to predict the future, doing forecasting or predicting, for instance, these readmittance rates for specific patients. So I'm going to briefly go through 3 different kinds of statistics which can be useful when incorporating in Diver. So the first thing is regression analysis. And for instance, in this plot, you'll see a lot of blue data points, and the question is, which line fits best through these points? Well, Diver can do this, but Diver only does a least square analysis. And least square analysis means that it can find the optimal straight line through all these data points. But there are so many seasonal patterns. So any doctor can tell you that the number of patients with the common flu or the common cold, it has a definite seasonal pattern. Any wine seller can tell you automatically that in December it's a huge month for wine. So a straight line just won't do. So let's use statistics to find a better line which suits our data much better. Second, clustering. Clustering is just a fancy word for finding similarities in your data points and finding meaningful groups in your data. That's what clustering is about. Third of all, if you've read Kathy's tweet about data governance, you'll know how much impact low quality data has on your business, and it's affecting millions of companies with gigantic losses. And the reason why is because usually when there's a wrong date or a wrong value in your data set, you won't know until someone drills all the way down to the lowest possible lines and then confronts you saying, well, your data is wrong, look at this. I've got this supplier that bought something on January 1st, 1900. So either they're a time traveler or your data is wrong. Or you've got this small town retailer that suddenly orders 100 million cases of wine. It's probably not going to be a gigantic fest there, but it's probably something wrong in your data. And you want to know that in advance. So what if we could do some mean-variance analysis, and we could pick out these kinds of wrong data sets before it influences your dashboards? Because most dashboards are based on KPIs, and KPIs are usually all about averages. So let's use our statistical screening to make sure we filter out these kind of data points before they mess up our dashboards. Okay. So we've got the R production, we've got R. Now we want to combine the two. So how would we go about that? Well, you've all got these. Everyone's got a colleague which comes up to you and says, "Look what I built on Excel, and it's great and flashy and pretty." And even though you don't really like Excel, you have to admit these analyses that are making in Excel, they're pretty good. So good that you want this on your dashboard, refreshed in an automated and logical way. So let's use the I production extensions for that. So if we were to make a statistical analysis right now, we'd have to take a gigantic long route. So we open up a marker, dump the data to some text file or CSV file, open up that in Excel, create the analysis, copy that analysis back into a data file, rebuild the model, and voila, you've got your marker. So instead of having to do all that, we're going to use a DI production extension to do this automatically overnight without having to press a single button. So extensions are a way to create your own nodes. So you've got a node that copies files, and there's a node that runs integrator scripts. So let's create our own node that runs R. So I've created my own node which runs R. And the great thing about this is that you can define your own parameters, and so you can define your own parameters, and the great thing is that only one person in the entire office has to know R. Because you only have to write your script once, package it into a production, and from then on, everybody on that server is able to run that script using their own parameters. So as long as you've got one person in office that knows how to do these statistical analysis, it becomes available for everyone, which is great. So extensions are like packaged, standardized nodes. And as long as you make these nodes generic enough and parameterize them, anyone can use them. Okay. So this is the default flow, of our BI process. So you gather your data, you twist and turn them around, finally you load them into models, and at the end you have your analysis, either through markers or dashboards or ad hoc analysis with ProDiver. So where does R fit into this story? Well, in here. Because Diver can't have it all. Let Diver do what Diver does best, and that's managing a massive amounts of data and creating those ad hoc models for your own analysis. So if you want statistics, use a statistical program like R. Have R create output, which is then integrated through Diver into your dashboards. Okay, so I've told you about BI production, I've told you about R, and I've told you about the extensions which will bring those two together. So now I'm going to give you a use case of how we create, through a dive board page, a way to do analysis on our sales. And I've been given a data set from John Stovecombe from Interreport, and all I know about this data is that it's Merlot wine. So you see a nice graph of our sales, and it's cases of red wine. And for the people in the back, at the bottom, you're seeing week numbers or month numbers. And for each month, you'll see the amount of sales of those cases of red wine. That's all I know. So we see that it's not very, very constant. There's a definite pattern in there. I don't know what the pattern is. Especially at the end, you'll see two spikes, two spikes, two spikes. Must be a pattern. I don't know. So let's see how we can create a R integrated version of this. So I've created this marker, and it consists of three major parts. In blue, at the bottom, you'll see a free entry quick view, and that will tell you, or in there you can enter how many periods you want to forecast. In green, that's the marker that's all about our data sales, and instead of built on a model, it uses a tunnel script to directly access our sales data, which will be handy later on. And the pure magic lies in the red square. It's a button, or it's just basically a rectangle with a click action. And the click action will start up our DR production script, and that DR production script will take the data from our sales, put it into R, have R create a forecast, then write that back into our data, and when it's done, it refreshes the page. So pressing the button, it will create this entire sequence, and eventually you'll see the forecast. Okay, what does the forecast look like? Well, like this, behold. What you see here in the middle is the line, that's the average of the expected value of sales, and around that there's this grey banner, this bandwidth, which is a 95% confidence interval, which means that 19 out of 20 times this is going to be accurate, which is pretty okay if you're thinking about forecasting. And well, I see people looking at this and thinking, well, you know, this is great, but does it work? Does it really work? And I'll show you in the next slide that it does, because if you look back, if you think back at the first example, you saw there were 53 weeks with 3 spikes. So what I've done, instead of taking the entire data set, I took out the past 10 months and I predicted those 10 months back. And this is the result. So in the red dots, you'll see the realizations as they actually were according to the data set. And in these cases, it's pretty good, it's pretty accurate. So this is an actual data set that I didn't change or alter anything. I just ran R, and this is what came out of it. So it's pretty accurate. And for you, it's now important to think about what this could mean for you. So this is just one graph on forecasting, but maybe you can create an entire dive board around all this functionality. You can have automated warnings based on stock levels, or on the number of scheduled patients or scheduled doctors. Do forecasting on that. Thomas van Praag has been doing some work on predicting POIs, which are post-operative wound infections. So we can create entire dashboards around this with an interactive component. And this is just the start of it. So, to summarize, you've got the production, which manages your flow. You've got extensions, which allow you to create your own nodes. For instance, a node that runs R. And using R to create our statistics, we can create highly interactive dashboards.